Scott T. Murphy here. I have been researching a thought experiment called the twin paradox and the effects of time dilation for over 20 years. Now I'm going to review the 30 websites I've collected and verify their answers with the time dilation equation. So here we go. At number 30, csicop.org. I like the twins designation, A and B. You know that B is the one that travels. They gave 15 light years. He turns around. They give the speed, the ages. The math is easy. It was going to get good marks, and then all of a sudden their page went down. The link you followed may be broken, moved, or abducted by aliens. Number 29, Einstein Online. Says forbidden. I think they changed their link. I'm not going to review them. They should change their website back to my bookmark. Number 28 says, how can we help you? Looks like somebody didn't pay their internet. Number 27, video unavailable. Number 26, video unavailable. Number 25, video unavailable. Number 24, the last of the video unavailables. Number 23, internal server error. At least we get an address for support. Number 22, PBS puts out a great page 404 not found error. Number 21, Internet Center. Big oops. Number 20, wow, NASA does not have the document. 19 says not found. Number 18, whoops. We had an oops, now we have a whoops. Number 17, Twin Paradox Net. Alright, a real website. We got a lot of great info, although it has no examples of the twin paradox story. Number 16, UNSW. I like this. It talks about light clocks being made of electromagnetic waves. That's good. We're all made up of electromagnetic waves. Talks about moving clocks running slower, the Pythagoras theorem. And the example that they give with Jasper and Zoe is not the twin paradox story. One does not turn around. It's more about comparing their clocks. Number 15, ucr.edu. This bookmark is part of a larger website. It talks about the Doppler shift, and when the traveling twin turns around, what occurs is a red shift to a blue shift. Number 14, ucr.edu. This example of the twin paradox uses the names Terence and Stella. Stella is the one that goes to a star and turns around. Now this example uses acceleration, and they acknowledge that time dilation is still happening when they say, quote, Stella's speed was changing throughout the turnaround, end quote. So all the information is a little complicated, and they give vague results, like less than 99% speed, and Terence ends up 14 years plus a day, and Stella is more than 2 years older. So they also didn't provide the turnaround distance, and I calculated it to be approximately 7 light years. Now, this website does have some good information on the space-time diagram, and they compare with a Doppler shift and an equivalence principle and other diagrams. Number 13, thoughtco.com. Now, this is the first example that gives precise ages for the twins. Although they start at age 20 when one twin leaves, you have to subtract out 20 from the answers he gives to find out the effects of the time dilation. He uses the names Cliff and Biff, so which one's traveling? He just says that they're going near the speed of light, doesn't say how close to the speed of light, and the turnaround distance I had to calculate is about 35 light years. Now, when summing up his article, he says, quote, Biff is absolutely the one undergoing more significant acceleration, and therefore he's the one who undergoes the least amount of time passage, end quote. And then 3 sentences later, he quotes, in 1913, though, Max von Lowe demonstrated that the 2 frames of reference alone are enough to explain the distinction without having to account for the acceleration itself, end quote. Number 12, utoronto.ca. Twins' names are Lou and Sue. We have to remember Sue turns around. And by the way, at 4.33 light years distance, they didn't provide the turnaround distance. I guess they didn't think that was important. Now this is the first example to be clear and precise on the twin ages at 10 and 5 years. And they provided 86.6% the speed of light, so we get to use the time dilation equation to verify their answers. If we plug in the numbers, the 5 years and the 10 years, we're going to solve for velocity. You can see the math here. And it turns out that the velocity is not exactly 86.6% the speed of light. They rounded it down, so keep that in mind. I guess they like the 5 and 10 years to set up their example. Number 11, Neatorama. I ranked this one higher because of the names. They used the subtler and the wilder one. It's easy to know the wilder one went on a rocket. The twin ages are given at exactly 50 years and 10 years older. Their animation is geared for children. It starts with a rocket. Then they switch to a train. Then they switch to a car, and explain it again in case the rocket or train wasn't good enough. They didn't give the speed of light, so I calculated it here. It looks like it's over 77% of the speed of light. And I also calculated the turnaround distance to be approximately 19.25 light years apart. And there's a quote about acceleration. He says, quote, for an accelerating frame, time dilation will not happen, end quote. Well, Einstein said moving clocks run slower, so I don't think this guy knew what he's talking about. Number 10, physics.org. This is just a news article, no explanation given at all. This is the first in this review to provide the turnaround distance at 4.45 light years. So good there. Names are earthbound twin, interstellar twin. Self-explanatory. The speed is given at 86% the speed of light. Now the ages are given as exactly 5 years for the traveling twin, and we're told the earthbound twin aged, quote, more than 10 years, exclamation point, end quote. So let's find out. We know the age of the interstellar twin is 5. We know the speed 86%. So we're going to solve for T, which is the earthbound time, Earth time. And it looks like T is 9.79 years. So they got the math wrong there. Number 9, ask a mathematician. This uses the names Alice and Bob. At least Alice starts with an A and B for Bob, who's the one that travels and comes back. I like this, talks about the Pythagoras theorem. And they did not give the distance at turnaround. However, I calculated it to be exactly a nice 3 light years distance. Let's look at the math. We put it into the time dilation equation. We have one twin ages exactly 8 years more, the other 10 years more, and the speed is exactly 60%. Now, when we do the math, we look at, there's no fractions. It's perfect. Number 8, minute physics. In this example, the author doesn't name the twins, he just says I and you, which means that I have to be the you that is traveling and churning around. Now, if I retell the story, I might have to change things around. Should I tell my friend him, meaning you, and should I tell my friend he's you, meaning him, or me? This example uses light seconds instead of light years. which is fine. It just seems kind of bizarre that they would show in their video a rocket ship going for 5 seconds and then traveling back for 5 seconds. Now let's look at the math. Twin ages are 10 and 8 seconds older. The previous example had 10 and 8 light years older, so the math is the same. They had 60% speed of light. Turnaround distance, I calculated 3 light seconds. Number 7, physics girl. The twins are you and her. Example given has twin ages as 26 and 30 years older at 50% speed of light. Turnaround distance not given. It is 7.5 light years away. Her results are consistent with the time dilation equation, as you can see the math here. I like this video for the first 5 minutes up until she says, quote, "She sees your clock running faster than hers, so you are aging quicker. It's during this period of acceleration that you become the older twin." End quote. It's more like she is getting closer to reality. Now, when she talks about gravity, I believe it is beyond the scope of this original thought experiment. I will say that Einstein said it was his wildest dream that acceleration and gravity are the same thing. Number 6, relativity trail. I like that twins are A and B. B turns around. This example given uses light hours instead of light years. The turnaround distance not given. I calculated it at 15 light hours. And they gave us the twin ages of 200 light hours and 250 light hours. So look at the math here. And indeed, they were going 60% the speed of light. That was given. I like the website also talks about space-time diagrams, its limitations, and with regards to Einstein's clock synchronization. It's good reading. Number 5, Wikipedia. A lot of good information here. Obviously, it's an encyclopedia. The example that they use has the twins' names as Alice and Bob. Although they switched it from what we're used to, we have to remember that Alice is the one that turns around and comes back. Bob at home ends up being 10 years older. Alice turns around at 4 light years distance. They gave that information too, at 80% the speed of light, and she ends up 6 years older. And looking at the math, everything is real easy. It's a pretty good website, except for the Alice and Bob. Didn't like them switching that. Number 4, Scientific American. The example of the twin paradox uses the names homebody and traveler. I like that. They've given the turnaround distance at 6 light years. The twin ages are 20 and 16 at 60% the speed of light. If you look at the math, it's good math, nice whole numbers. And this website explains the twin paradox story very informatively, concise, and easy to understand. Number 3, Virginia Tech. I like to use the names prime and unprime. Just like in the equation, T prime is the traveling twin, so it's easy to remember. They gave all the information, turn around at 1 light year distance, 80% speed of light. The traveling twin goes, and they end up aging 2.5 and 1.5 light years older. Looking at the math, it's pretty easy math. And this website covers all the basic concepts. And this has been a reference that I've used for many years. Number 2, The Rest of Us. This YouTube video has the Earth twin and Space twin. Those names are self-explanatory. That's great. They've given the turnaround distance at 4 light years and 80% the speed of light. The space twin travels and they end up aging 10 and 6 years older. If we look at the math, this is a great example, And the video has good visual graphics. They go into the history and how the twin paradox story came about. And at number 1, Scott Tee's Science. This is my video and is the only one that has more than one example of the twin paradox. The first one, twins' names are A and 1. Easy to remember, Earth has the letter A in it, and think of Spaceship 1. Twin 1 was traveling 50% the speed of light, turns around at 20 light years distance, and the result is that twin A ages 80 years at home, and twin 1 ages only 69.28 years. In my second example, I go 4 times better than twins, with octuplets, named A at home and 1 through 7, with speeds from 30 to 90% the speed of light. You can see the results here. Note, these results are for a one-way journey. A light clock is a tool physicists use to draw out a right triangle so we can then see the Pythagoras theorem to prove the longer length translates to a shorter time. In my first video, I point to the triangle's corners. Not until the second video, I draw it on the screen for you. My animation has light clocks with the dashes representing light moving too fast. That's bad. However, the animations are better than a space-time diagram because we can see from an infinity point of view. It shows 2 dimensions of space and the history of light the astronaut would see forward and from behind at any given moment. The formula at the end is wrong. This is the formula I meant to show, which is the same time dilation equation with the terms moved around. I like this variation better. Finally, I have the animations on my website, scott.t.tv. Click my blog, then Twin Paradox Animations. Well, that's it. I hope you enjoyed it. Please visit my website. Thank you very much.